Hello everyone, my name is Rajashri Rajendra Bhagwat. I am from Rajaram Bapu Institute of Technology. Now I am going to explain the use of position encoder in robotics. What is meant by position encoder and why it is used? A position encoder, which is also called as a shaft encoder, is an electromechanical device that converts the angular position of shaft or an axle to an analog or a digital code. As we know, there are two types of systems. First is an open loop system and second is a closed loop system. Figure A shows open loop system and figure B shows closed loop system. If we take an example of work table in which stepping motor and gear is used and work table moves across lead screw. In case of open loop system, the position of work table is not given back, so it is not giving much accurate results. But in case of a closed loop system, the position encoder is used which gives the current position of work table as a feedback signal to comparator. Comparator compares the current and required position, gives error signal and take corrective action to remove error. Position encoder increases the accuracy in work. There are mainly two types of position encoder. First is absolute and second is incremental. The output of absolute encoder indicates the current position of shaft. The output of incremental encoder provides information about the motion of shaft, which is typically further processed elsewhere into information such as speed, distance, and position. There are mainly four encoder technologies. First is a conductive, second is optical, third is a on-axis magnetic, and fourth is a off-axis magnetic. Here we will in detail discuss about optical encoder. Optical encoder use code disk that has one or more circular tracks with some arrangement of identical transparent windows in each track. A parallel beam of light from a set of light emitting diode is projected to all tracks from one side of the disk. The transmitted light is picked off using bank of photosensor on the other side of disk that typically has one sensor for each track. The light sensor could be silicon photodiode, phototransistor or a photovoltaic cell. Since the light from a source is interrupted by an opaque area of a track, the output signal from a probes is a series of voltage pulse. It gives the square waves as shown in a figure. This signal can be interrupted to obtain the angular position and angular velocity of a disk. Note that the pulse width and pulse to pulse period, that is encoder cycle, are constant in each sensor output when the disk rotates at a constant angular velocity. When the disk decelerates, the pulse width will accelerate, and when the disk accelerates, the pulse width will decelerate continuously. The shaft position encoding is used to show the angular position of shaft. Here is an example of a binary code with three contacts. In general, when there are n contacts, the number of distinct positions is equal to 2 raised to n. In our example, we are using 3 contacts. So, the number of distinct positions is equal to 2 raised to 3 is equal to 8 positions. The 3 concentric circular rings shows the 3 contacts and the 8 positions are shown by 8 tracks. Here, black sector shows on and the white sector shows off. For first case, 0, which shows angle from 0 to 45, has a binary coding 0 0 0, thus it shows off off off. For sector 1, which shows angle from 45 degree to 90 degree, has a binary coding 0 0 1, thus it shows off off on and so on. Here we are using a Firebird 5 Atmega 2560 microcontroller. If your robot has 2 wheels, you require 2 position encoders, and if your robot has 4 wheels, you require 4 position encoders, and so on. The position encoder disk is mounted on an axle of a wheel. As axle rotate, disk rotate and give pulse. When left position encoder count pulse, the left position LED glows. When right position encoder count, then right LED glows. The figure shows the position of LEDs on Atmega 2560. Calculation of position encoder resolution. A encoder resolution is a distance by which the encoder disk rotates for one pulse count. Here alpha is angle between slots. If your encoder disk has ns number of slots, then encoder resolution is equal to 360 divided by ns. If your robot moves certain distance in which the number of pulse count required to move this distance is given by the formula NP, which is equal to pulse count emitted by encoder equal to angle of rotation of encoder shaft divided by angle between slots. Now if we consider that our robot has a two wheels, then the two wheel diameter is equal to d. Then wheel circumference is equal to d into pi. Number of slots on each encoder disk is equal to n1. Then position encoder resolution is equal to p by n1. As we have already discussed, position encoder resolution is the distance by which the encoder disk rotates for one pulse count. If we go for a second case, in second case one wheel rotate in a clockwise direction while other wheel rotate in an anti-clockwise direction. Then the distance between two wheels will be L. Then the radius of a circle formed in 360-degree rotation of robot is equal to L by 2. As the center of rotation lies on a middle of disc between two wheels, that's why the radius is equal to L by 2. Then distance covered by the robot in 360-degree rotation Q is equal to L into pi. Number of wheel rotation in 360-degree rotation of robot is equal to Q by P. Then total pulse required for the 360-degree rotation of robot is equal to N1 into R1. Then position of encoder resolution in degree is equal to 360 degree into divided by N2. If we take a third case in which the one wheel is rotating in a clockwise or anti-clockwise direction and the other wheel is stationary and the distance between the two wheels is L, then the radius of circle formed in 360-degree rotation of a robot is equal to L. In the second case, the center of rotation will lies on one of the wheel, so the radius is equal to L and the distance covered is equal to 2 into L into pi, and the rest of the calculation is same as the second case. Now if we want to write a program for the position encoder, here is the flow chart for the program. First is the start, second is the initialization of ISR. ISR stands for the interrupt service routine. We are using ISR for writing our program. Then we are initializing the shaft count left is equal to A and shaft count right is equal to B. Here A stands for the left shaft position count and B stands for right shaft position count. Then give the encoder resolution value. Then take an input of required shaft count value from user. When we start motor, then the values of A and B get incremented. Then compare the values of A and B with C. If A and B values are greater than or equal to C, then stop the motor, and if it is less, then go for the incrementation of A and B. Here are the simple programs. In Firebird 58Mega2560, we are using pin number 5, that is int 5 for external interrupt for right motor position encoder, and pin number 4, that is int 4 for external interrupt left motor position encoder. Here is the simple program for the rotation of robot by a specific degree. Angle rotate is the function name, then required shaft count and required shaft count int is equal to 0. Here the required shaft count shows the position encoder resolution and the required shaft count int shows the required shaft rotation. Then initialize the shaft count right and shaft count left to 0. In condition, if shaft count right and shaft count left are greater than or equal to the shaft count int, that is the required shaft count, then stop motor. If it is false, then go for the incrementation. If we write we can also write the program for moving robot by a specific distance, that is forward and backward. Thank you.